All right, guys. So I'm out today. I thought a good lesson would be to recall solving quadratics. Okay, a very important lesson in our Algebra 2 Semester 1. So you're remembering back to Semester 1. Mostly should be a review, guys. Quadratics, continue to come up in mathematics, so that's the reason I chose this lesson for today. So if you remember, there's quadratic equations that are factorable, and I'm going to write one of those out here. This quadratic equation you can solve simply by factoring it. Okay, and what do I mean by factoring? I mean, look for numbers that multiply to that last term, the constant, -35, and add to the middle term, +2. So here you'd have 7 and -5. They do that. So this left part you could factor to x plus 7, x minus 5. This is like, undoing the foiling is kind of how we described it. And then you can take the factor and both factors, set them equal to 0, and that gives you your two solutions to the quadratic equation. In this case, 5 and -7 are your two solutions to this quadratic equation. Okay? That was a very simple quadratic. Okay? Could easily be factored. Remember, okay? Quadratics, they can have real solutions, two real solutions. They can have two imaginary solutions. Okay. One real solution. Okay. So there's different types. Okay, this one happens to have two real solutions. They're rational numbers. Okay, if you start getting to irrational, to imaginary, then factoring doesn't work. Okay, there was another method. Okay, and that method was called the quadratic formula. And just to write out the formula for you guys, it's x equals -b plus or minus square root of b squared minus 4ac all over 2a. Okay, and this, you could use this when a quadratic was in standard form, and so that is ax squared plus bx plus c. It had to be equal to 0, and so you get a, b, and c and plug them in. That gives you your two solutions. You can use this to solve any quadratic. And it was kind of like the last thing we learned in that chapter. We learned all these other methods, and then we're like, hey, here's a quadratic formula, and it can do all of these problems. Okay? And so it can do the simplest problem. We could solve that other one using the quadratic formula, all the way to the most difficult where you have imaginary solutions. So I wanted to do an example using the quadratic formula. You guys typically like to have a scientific calculator maybe to help you with your calculations here. But if we had 2x squared plus x plus 7 equals 0, guys, we could identify a as 2, b is 1, c is 7 here. Okay, this thing's equal to 0 already, nothing to do there. So x equals -b, we're going to substitute 1 in for b, plus or minus, square root of b squared, so 1 squared, minus 4 times a, which is 2, times c, which is 7, all over 2 times a is 2. All right. From here, it is just simplifying. I typically start inside of my radical. Guys, 1 squared is just going to be 1. Minus 4 times 2 is 8. 8 times 7 is 56. And then all over 2 times 2 is 4. So this simplifies to -1 plus or minus the square root of -55. over 4. Apologize for the bell, guys. Working here on a school day. And so simplifying this further, guys, recall, this is just a side note here, that the square root of -1, that's our imaginary unit. That's equal to I. So what happens here, and I typically, back when we did this lesson, I would skip over this step, but I'm just going to highlight it today. So the square root of -55, guys, you could write that as the square root of -1 times the square root of 55. And so that's where we can take that square root of -1 and we simplify that to I radical 55 over 4. Okay. And so that would be our solution to this quadratic. There are two solutions, our two imaginary solutions. All right, guys, hopefully a quick refresher, guys. There's all sorts of types of problems in here. Like I said, you can have real rational solutions, real irrational solutions. I've got a couple that are factorable for your homework, and then a couple that you'll find a little tougher. Definitely want to use quadratic formula on. So thanks for watching, guys. Hope you have a great day, and we'll see you here soon.